Now let us go ahead and make it simpler. As I have said, this also I have explained it in the class, that if I give you a center which is the XCYC, let us say I give you a center and I give R as the radius and draw a circle, and then I have got a point which is, let us say the point here is A, XY. Now you want to check whether this point is inside the circle, outside the circle, or on the circle. This is probably easiest of all, because here all that you have to do is to join that point with the center of the circle, find out the distance, and whether to compare that distance with respect to R. If the distance is less than radius, point is inside. If distance is equal to radius, point is on the circle, and if the distance is greater than the radius, the point is outside. The answers are only 3: in, on, or out. Okay. So this is also another problem. Write a pseudocode. Everywhere you assume that you have got a servant who is absolutely dumb, who doesn't understand beyond simple basic processing, and you have to write the steps in that fashion. And the last point is, now of course this is a little more complicated, and this is probably will tell who are smarter boys or who are intelligent ones. I have got a triangle, and the 3 vertices of the triangle I have indicated over here are minus x minus y, that will be the point on the left hand side bottom. Then it will be my x and minus y, that will be the point on the right hand side, and the point on the top vertex is 0 and y. So suppose x and y are the numbers, integers let us assume, and you have drawn this triangle, and you have been given a point, and you have to check whether this point is inside the triangle, is it on the triangle. Now when you say on the triangle, it could be coinciding with the vertex, or it could be lying on the edge. There are 2 aspects. If it is coinciding the vertex, it is still on. If it is on the boundary or on the edge or on the line, it is still on. Okay. And then there is outside the triangle. So this is probably the, if I have to say something which is the most difficult problem in the assignment, this is the most difficult problem, though I don't consider it to be very difficult, because you can make use of your solutions of the previous problem. Okay, this is the tip that I am giving. Make use of the solutions of the previous problem, invoke that solution several times, you will get the solution of this problem. Okay. And the last one is not a geometric one, it is a slightly different one. It's very, very simple problem. All that you have to do is to, if I give you an integer k, enumerate and print the first k odd integers, you know. So obviously you start with 1, which is an odd integer, and enumerate the integers actually. I mean, this is a very no-brainer actually, sort of, you know, but I thought it will be easy for many to write down. The point is not mathematics. Please remember, there is no mathematics that I am going to check as much. What I want to check is how you can break down. You can break down your logic into simple instruction. Each instruction should be very clear, unambiguous, will do only one thing at a time. And you have to write down those instructions in a sequential fashion, so that you have got the starting point, you have got the ending point. And that is the art, and that is the skill of computer programming. Okay. And that is what I am going to now come up, what we call it as the structured programming. This is a very important part. There are different paradigms of programming. We are not going to discuss all of them, but it will be useful for you to understand what is a structured programming. Now there are the computer scientist by the name Dijkstra developed a theorem saying that any solution which you have can be converted into a structured procedure. What is a structured procedure? Now all algorithms will have one entry and one exit. Okay, so there are of course some people who think multiple entries and multiple exits, but we will right now restrict our discussion for one entry and one exit, number one. Number two, all steps can be grouped together in the form of constructs. There are only three constructs that you can think of. One is, and I will explain those constructs to you, besides of course the read and write instructions. There are some basic constructs which I will explain to you. Any group or block of instructions will consist of only these constructs. That means you cannot have the logic. You have to break down that logic so that each step will only involve these three or a combination of them. And repetitive instructions can be clubbed together as the subroutines or functions or programs. So anytime you want to invoke the same thing again and again, you define it once and only pass the parameters and invoke it as many times as possible. Now the three important constructs which I want to mention to you, the first one is what is called as, so flow charts or the diagrammatically this is like the sequence of statements. This is one construct, and that is what I have shown over there. S1, S2, etc. So each one is a sort of an assignment statement. For instance, if you say a D, for instance, now this is a statement, that is, take the input x1, take the input x2, take the input y1, take the input y2, do all the calculations on the right hand side of the equation. Whatever is the output, you assign it to D. Okay? And since it is an assignment, instead of saying equal to, we use the arrow actually. So that is an assignment statement. So you will find that such statements are combined together, and we generally call it as the sequence of statements. This is one construct. Okay, you will find that this has to be used obviously in our programs. Left side is always a variable. It's not an expression. It's not I can say x plus y is equal to something something something. On the left hand side you have got only one variable which has to be given the assignment actually, and then right hand side will be an expression. So this is one construct. The second construct, which is very important, is a diamond. So here also one entry, one exit. Here also there is one entry and one exit. And the expression is the following, that there will be some condition. Okay. If that condition is true, then do S1. If the condition is false, then do S2. And this is the way it is written here. Begin and end is just a depending on the language that you will use. Sometimes it is parenthesis, curly parenthesis, sometimes it is the phrases like begin and end, will vary from language to language. But this construct is very important, namely if B will be a condition, that condition will have outcome of either true or false. Okay, nothing beyond that. If the condition happens to be true, then do S1, okay, and come out. If the condition is false, then do S2 and come out. Okay. So here you will find that if it is yes, then do S1, come out. If it is no, then do S2 and come out. Okay. So this becomes very important, because in the logic that you will have to worry about that if this is the case, do this. If this is the case, it is do this. There could be nesting of it. You can have if B equal, if then S1, S1 could itself be another condition, that S1 could be another condition, that if B1 is yes true or false, so there could be S2, S3, etc. So nesting of these conditions is possible, which we are not explaining right now. I am sure when you will start programming, you will work on those. But the basic three constructs I want to introduce is, first is the assignment statements, and then the combination or the compilation of these or sequence of statements. Second one is the condition. If